The world's energy needs will double by 2030. Our long-term energy future, economic growth, and environmental health all depend on a commitment to producing more energy from domestic renewable sources like wind, solar, and sustainable biomass. Currently, over 50% of every kilowatt produced in America comes from coal. This means that even the electric car runs mainly on dirty 100-year-old technology. Much-needed EPA mandates and stricter air quality standards will pressure coal-fired power plants into unprofitability, creating a great need for our nation's energy supply now and tomorrow. These needs translate into great opportunities for can-do American companies to step up and deliver real energy solutions. My name is Michael Smith, and I am the CEO of CEG Power and Gas of Mays Landing, New Jersey, a sustainable biomass company. I am also the founder of Mother Earth Energy Incorporated, a 3.5 million gallon a year biodiesel facility, the first of its kind in the Philadelphia metro area. Our work with lipid oil crops such as canola, switchgrass, soybeans, and algae gives us a unique perspective into the state of today's biomass industry. The main challenge faced by biodiesel manufacturers is essentially the same challenge faced by sustainable biomass companies. Where does your feedstock come from? This question led us to take a hard look at alternate feedstocks. Our lab tested all kinds of options from algal strains to genetically modified grasses. What we learned is that while most of these options are promising, they have yet to realize their full potential. As an example, billions have been invested into algae, and not 1 kilowatt hour of energy nor gallon of commercially available fuel has been produced to date. Algae's promise outpaces its reality. And most forms of biomass are not sustainable at commercial scale, like forest debris, canola, or switchgrasses. Our options were getting very slim. That was until we stumbled on a small native plant called duckweed. And what a stroke of luck it was. Duckweed is a free-floating aquatic plant found with worldwide distribution. Renowned for being the world's smallest flowering plant, duckweed reproduces both sexually via flowering and asexually via budding, leading to tremendous growth rates. In fact, duckweed is the fastest growing multicellular plant in the world. During the growing season, it is common to see communal duckweeds growing in undisturbed pools of water throughout the continental United States. It is very likely that the average American passes by vast communities of these plants every day without giving them a second thought. However, this tiny aquatic plant has the immediate potential to answer our nation's call for an American-made, cost-effective, renewable energy source. Duckweed is a fantastic candidate for sustainable biomass because it grows so rapidly, it doubles its body weight under ideal conditions every 24 hours. It has 5 to 6 times as much starch as corn and does not contribute to global warming. Duckweed is also considered a carbon-neutral energy source because, unlike most fuels, it actually removes carbon dioxide from the atmosphere during its growth cycle. Duckweed also functions as a bioremediator by effectively filtering contaminants such as bacteria, nitrogen, phosphates, and even heavy metals from naturally occurring bodies of water, as well as waste and gray water streams. Here are some interesting facts. Duckweed is the world's fastest growing multicellular plant. It has as much carbon and energy per pound as some types of coal. It can be grown year-round and harvested daily. And unlike algae, it has millions of cells per plant and floats for easy mechanical harvest. Duckweed is the ultimate flex fuel. It can be pelletized and burned in traditional boilers with little to no modifications. Starches from duckweed can be utilized to make ethanol. And our patented gasification process creates a carbon-rich biochar and a high-energy, no-drill biogas that could replace hydraulically fracked natural gases. This biogas can be used just like natural gas to heat homes, run turbines, generators, even vehicles. Further processing of the biomass can make liquid fuels like methanol, kerosene, and jet fuel to power cars, trucks, trains, and planes. And duckweed's lipid oils can be used in the production of biodiesel. Plus, the duckweed inhales CO2 and exhales oxygen, making for an extremely effective carbon sink. And finally, duckweed produces significantly less emissions than coal and other traditional forms of energy production. Several years ago, the Waxman Institute of Microbiology at Rutgers University was one of the first U.S. academic institutions to recognize the potential of duckweed as a bioenergy resource. The Waxman Institute applied to the Department of Energy to fund the DNA sequencing of the duckweed genome in certain duckweed species. It is believed that the genome of duckweed will provide invaluable fundamental information for further energy technology development.
It's amazing how different this plant is from everything else. And so it was in the back of my mind when Todd Michael suggested that we submit a project to DOE for sequencing. And so he said, what kind of plant should we do? And I said, well, duckweed's the fastest growing flowering plant. And if you're interested in biofuels, that's the equivalent of being interested in biomass. And so we started looking into it, and it turned out that duckweed has really interesting characteristics for biofuel production. There are 5 genera and about 40 species of duckweeds. The smallest ones have doubling times on the order of 30 hours. So every day and a half, they double their biomass under ideal growing conditions. So that's extremely rapid.
The Waxman Institute has been an invaluable resource for us, and our continued collaboration with the Institute has led to major breakthroughs in our sustainable biomass technology. We have enlisted the help of the Waxman Institute under a collaborative research agreement. Expanding our knowledge of this plant, including its genetic potential, will further our emerging technologies. Over the past 3 years, we have developed methods to grow the plant in modern greenhouses, and using advanced harvesting techniques, we are able to literally farm duckweed on a daily basis, essentially making us carbon farmers. The duckweed we harvest on site allows us to utilize our patented gasification technology to transform the duckweed into usable forms of energy. Our technology creates a methane-rich biogas that can be used to run conventional generators, or by harnessing the waste heat from our process, we can run steam turbines for the production of electricity. This allows us to have 2 wholly separate and complete products: a no-drill, no-impact natural gas equivalent, as well as a virtually emission-free electricity production system. Our unique process of returning the CO2-rich exhaust streams back to the greenhouse feeds the next generation of duckweed. Our carbon-neutral approach fosters a better environment with positive health benefits for Americans by increasing the air quality and displacing dirty, antiquated technologies like coal. And unlike wind or solar, our power generation is dispatchable, meaning we are not waiting for the wind to blow or the sun to shine. We can produce power on demand. This allows for more steady power distribution into the existing grid without taxing the system. Our technology is not pie in the sky. It is a reality, right here and right now. Our pilot scale plant at our research facility in Mays Landing, New Jersey, where we farm our biomass directly on site and convert it to usable energy, can power several homes, with the pond the size of a swimming pool, making it among the most advanced biomass facilities in the country. Our successes at the pilot plant level has garnered the attention of major banks, financiers, and industry experts. And as such, we are slated to begin construction on several commercial power plant facilities, the first of their kind in the country. These facilities will create hundreds of well-paying, full-time jobs at all skill levels and deliver clean, green energy to the country. Sustainable biomass technology is available right now and right here in the U.S. Our process costs less and uses less land per megawatt than traditional solar installations. And unlike wind and solar, our systems can be used as baseload facilities and operate 24 hours a day. CEG Power and Gas has begun to license our exciting new technologies to qualified commercial clients. For more information, please visit our website at www.cegpower.com.